Okay, well we're picking up where we left off after I screwed up. So we'll just refill all this. Okay, so we have our variables listed. We have our rearrangement done correctly this time for pressure, not for volume. And now we're going to plug everything in. Okay, so we've got all of our numbers plugged in. And now we'll compute and get a raw... Well, first of all, let's do a little bit of dimensional analysis before we do anything else. That's the other nice part about using all of the units in the ideal gas constant. You've got a lot of rearrangement here, and doing dimensional analysis helps you sort of prove yourself correct. So we've got moles here divided by moles here. Those cancel. We have kelvins here as a numerator times kelvins. Those cancel. We have liters here in a numerator. Excuse me, those kelvins were in the numerator or denominator. We have liters there in a numerator divided by liters. Those cancel. The units we're left with are ATMs, and that's the units we want for pressure. So it's a nice double check on yourself. Okay, so what's our raw number? Okay, so we get a raw answer of 2.01426.715, etc. ATMs. The book claims that you have 3 sig figs. We know better because that only had 2. So our final answer for pressure is 2.0 ATMs. This is really easy algebra. This is not difficult. It's just a little bit tedious. So let's try... the other thing that we can do, of course, is because we have a way to figure out moles now, we can take that to mass. So there are going to be problems where you have to do both an ideal gas law problem and a factor label. So let's do one of those together also. This is actually page 345. So, and this is number 1 in the practice at the top. We want to know how many grams of CO2 gas there are in a 45.1 liter container at 34 Celsius and 1.04 ATMs. So of course the first thing we do is we write Peaceful Valley equals NERT, and then we're going to list variables. So pressure, volume, number of moles, ideal gas constant, and temperature. Our pressure is 1.04 ATMs. Our volume is 45.1 liters. Our temperature is 34 Celsius, which gives us 307 Kelvin. We're in ATM, so we're going to want to use 0.0821 ATM liters over mole kelvins. And we don't have moles, but that's not what we're looking for. We're looking for grams. We're looking for mass. But if we can get moles, we can then do a factor label that will get us to mass. So we'll start out by rearranging for moles. So PV over RT equals number of moles. And now we're ready to plug in. Okay, so we'll do our dimensional analysis check. ATMs divided by ATMs, liters divided by liters, kelvins divided by kelvins. We end up with moles, which is what we want. And what's our raw number? Okay, so we have a raw number of 1.8609, etc., etc., etc. But that's not our final answer. So what we need to do is put that entire number into a factor label. That many moles of, and we are dealing with CO2 gas, has a mass of how many grams? Well, it just so happens we just did the molar mass of CO2 on the quiz. So we know that 1 mole of CO2 has a mass of what? Do you remember? Let's see. 12.01, 16 times 2. So 32 plus 12.01, 44.01. So 44.01 grams of CO2 in 1 mole of CO2. So what is our raw answer? Okay, so we've got, this is a raw number, and we can only have 2 sig figs because we're constrained by this. The book claims otherwise, but they're wrong. So our final answer is 82 grams of CO2. Okay? If you're given something in grams and you're asked for a pressure or a volume or something else, obviously you're doing the factor label first. I've given you some practice problems, 16 through 20, parts A and C only. They're all 3 parts, but you don't have to do part B. If you feel like you need extra practice, you can do part B. And you're going to work on those, and then you will have a FIP quiz the next time we all meet, which will be Wednesday, because tomorrow, even if you were, tomorrow is just off the table.